This conference will now be recorded.
Hello, everybody, and thanks for coming. My name is Rod Soto, and we're here today at a HackMiami meeting. We have one of our best and brightest, which is our very own Sam Greenfeld, and he's gonna, like always, it's gonna give us some insight has to do with OCR and exfiltration of data. I am positive that this will be an awesome presentation. I think this is a presentation that will be featured with more extensive details in Las Vegas this year, and Visas specifically. Talking about Las Vegas, for all of you who are not at the Discord, please join Discord. We are already making plans to some will go, some others will be virtual, but there's definitely something's gonna happen physically in Vegas. We're still waiting, I guess, marching orders from DEFCON. I understand that Black Hat will be sort of a hybrid event, and so probably will be DEFCON. And if that's the case, and you feel comfortable going for any reasons, I was able to get actually very cheap fare, airfare. So this is a good time to plan and start getting ready. Hopefully I will see some of you there, and we get to put our skills to test and maybe win some. So other than that, I don't have any more updates for you. We're looking at June, July to get a update from the library. As soon as we get it, we'll make a call. I was thinking that probably it's going to be after DEFCON, if we come back, and then maybe we can do one meeting in person, one meeting recorded, or via Zoom, or go to meeting like we're doing right now. Other than that, I don't have any other updates for you. I'll thank you very much. I hope you're safe. And with that in mind, I'm going to give Sam the floor now.
You have to make me presenter.
Yes, sir. Thank you very much.
You see the screen now? Okay.
I do.
Okay. Let's see if this make GoToMeeting's little window doesn't, or does it collapse? Still, I don't know. There it goes. They changed the interface. Okay. Well, the talking. Let's see. Analog hole refers to a time back when instead of these digital outputs we had, which tried to keep things perfect, you had these infinitely varying outputs within a range, which you could pretty much do whatever you wanted to with the signal. But more specifically, it refers to the time back when, not the time necessarily, but just the general fact that if your eyes can see something or your ears can hear something, then you're always going to be able to capture it pretty much always with another device like a camera. So Sam Greenfeld, I used various nicknames because I'm a bit late to the whole social media party. Had a CISSP for about 11 years, and I'm in various groups. Today we're going to do a bit of an introduction, how OCR works, look at some results, look at some related texts, and talk about potential countermeasures you could use. So optical character recognition. These are just, in general, these are automated methods to identify printed or potentially handwritten text in an image. The general concept has been around with photoreceptors as far back as the late 1800s, early 1900s. Many of the old older systems were attempts at doing things for the blind. Around in the 1950s, Reader's Digest magazine was the first commercial user of optical character recognition, where they took typewritten documents, and made and attempted to convert those to punch cards to feed into computers and tabulators and other things, which took punch cards as inputs at the time. By the 1960s, you had postal services like those in the United States and Soviet Union were using OCR to sort letters. And by the 1970s, you have had your flatbeds, and you don't see them anymore, handheld scanners that you could purchase at a store. OCR in general started with targeted characters and fonts, but it's now more general. You can feed whatever you want to into these engines, and it tends to be a very mature technology. Why did I decide to look into OCR? It's widely available, can be done outside of a system. You're not going to necessarily be alerted that anyone is taking a picture of a screen. Users have to be able to interact with text. If you block their access to text, you may make it difficult for them to do their jobs or slow them down. Text also tends to be a limited number of colors and sizes. So if you put other objects on the screen in an attempt to make copying it difficult, or put a watermark to try and declare ownership, it's going to generally look very different than the text. Image precision is generally not super important with OCR. It can take some tolerances. It's not like we're trying to look at a diagram on a screen and it exactly map out the length of each of the lines. OCR can be used to remove non-text data, which could be used to identify a source. Recently, you had I believe there was the Intercept news site online I saw posted a quote unquote reconstruction of a government document as opposed to posting the original. They may have learned that if you put the exact source on, they've gotten good at tracking down who the leaker was. And also looked into OCR because the focus tends to be on larger data breaches in the news, but smaller data breaches tend to do happen a lot more, but you just don't hear about them. Business impact. If OCR could be used to extract user data, like information about your customers. This is like when you have a skimmer on an ATM, gas station, a pump, or just an employee at a store just going around copying credit cards. You may not get all of the data, but you'll get at least some of it. And then you can then potentially mix that with data leaks from other sources to obscure the origin. This could be things like company data, what was announced at your latest all hands meeting. It also could be things like pricing sheets and battle cards to deal with your competitors. You could potentially lose a sale because someone copied your competitive information and not even know why you lost it. For operations, this could be small pieces of data like firewall rules or access keys or passwords, which may result in larger data breaches afterward. For product development, this could be timelines of unreleased features, or potentially even pieces of source code. You could think of it like in the HBO Silicon Valley series, where you had the Hooley duplicated Pied Piper's algorithm by reverse engineering it. Instead, what if they just had a picture of the source code? Because the core source code probably is not that big, and they just copied it from. Cameras in general work for both monitors and paper. They don't really care what you point them in, and they're getting smarter all the time. Here we're looking at Samsung's smartphone's stock photo application. The little T in the circle icon means it's identified there's text on the screen. And since it found text on the screen, it's more than happy to try and help us scan the document it in while cropping it and isolating it from the rest of the picture. I did some research to try and figure out if there were known OCR attacks in the past. However, I've not had much luck finding them. I presume, therefore, this is largely a theoretical attack. But Here are some examples of things that have happened since the start of the year, which are picture related. In the Netherlands, pictures were taken of two data systems used for COVID-19 testing and contract trading. These included people's addresses and their national identification numbers. The criminals were caught because they advertised that they wanted to sell the information. Some of the screenshots which were redacted and copied in this news article show what's obviously are spreadsheets. Therefore, this is iPrime data, which you could use optical character recognition to pull the data back from the pictures and then exploit them by putting them elsewhere. In Bulgaria, a high-ranking official spent an hour and 20 minutes taking photos of classified information, and was known to be involved with Russian spy ring. They know the length because of the hidden camera, but it's not disclosed what was lost in that case. In the United States, here, if you are familiar with the Digital Millennium Copyright Act, every 3 years the Librarian of Congress has to decide what exclusions are allowed to the rules about breaking encryption and other things to access a work in order to do alternative things that the original publisher may not want. Here, in one of the comments this year, the American Association of American Publishers actually prefers that someone would use optical characterization to circumventing the encryption protecting a work if you were trying to make it more accessible to handicapped users such as the deaf and the blind. This is not the first time this has come up either. Maybe a decade before, the Motion Pictures Association, the MPAA, just said that they prefer that if a teacher wanted to reuse information from a video, they should point a camera at a monitor and re-record it that way. On the Association of American Publishers notes that yes, this is slower, but Google was still able to amass a huge library of books via OCR for their library search tools and other uses. How does OCR work? We're just going to talk about this in general. The exact steps used and approach may vary by program. First, most OCR engines operate in a two-color environment. You don't necessarily care about if you have a colored text or it's maybe grayscale, you want things in two colors to start with. Next, the engines will typically rotate the image so they're in a known good orientation. You have to normalize the size of the image, both in height and width, to match what the engine is expecting the character's size to be. You have to then determine what you're interested in. Different engines may look at different things, and some engines may look at several things. You may want to look at characters, you may want to look at words, you may want to look where the punctuation is, or maybe at whole paragraphs. These may be areas of interest, may vary by program and purpose. For instance, if you're looking at a table, the engine may want to reconstruct the table to export it to Excel, or just say there's a table there. If you're processing form information, you can look for the form fields and extract information from those. And finally, you're processing the results. Very crudely, you're going to look per character. Per character engines, if you see one letter, you might be able to use that to help you figure out another character you were uncertain about. You could try to do this for the crude models, such as an image comparison. You may look at the glyphs, say a capital letter A is made of two diagonal lines with a horizontal line in between. You may try to process things per word. A lot of OCR systems have been either trained on or include word dictionaries, and one may try, if they're uncertain about a letter, they may try to guess which word it looks the most like. You may look at things per sentence, just like your keyboard on a smartphone tries to predict what's ahead. You can do that with optical character recognition as well. And there are lots of models out there, as we discussed, image comparison, glyphs, and even you can also go into machine learning. Probably many models today use machine learning. most popular neural network, at least I saw in some engines, is the long short-term memory neural network model, which has a concept of forgetting and remembering things for extended periods of time. These are also used for voice recognition in addition to other forms of language processing. I skipped over a step because you don't typically see it, but the first step you actually would have to take if you're taking a picture from the outside is a perspective correction, which is why you saw the camera app before show a tap to scan icon. So once you do that, these apps typically either here, or you could do this in an image editor on a PC, you typically mark off where the edges of what you're interested are. On the left here, we're using Samsung's app again. On the right, that's Microsoft Lens, which is their OCR app that you can put on a smartphone. And you can just, once you do that, it'll crop the image and attempt to make it look more correct to what you would expect to see. For instance, here's a flattened version of the image that we were looking at on the previous page. Now there are some optional techniques that really aren't optional, but to an extent they may be if you're just doing a pure engine, such as noise and line removal. You may want to remove everything that's not text off the screen, and or if you have like a line through a fax because of a bit error, you could potentially get rid of it. You can do script language recognition if you're not certain what you're looking at. Some OCR engines are familiar with hundreds of languages as long as they're typewritten. They tend to handle only a few languages if they're handwritten. And while layout analysis isn't strictly optional, you always have to identify what a paragraph is or something like that. You could potentially be trying to do that to reproduce the layout in another format and reproduce the exact layout that you imported into a Word document or similar. Also in the finance industry, for example, invoices and payment receipts and things like that tend to have known fields you can look for, and those can often be processed by OCR. Originally, I was starting to think I was going to write a bit of an OCR custom solution, set it loose, looking at a bunch of images from a test app and see what the results are. But then I realized there's a ridiculous number of OCR engines out there already that you can access. I cannot vouch for any of the applications on this page. This is just the first page of results from the Google Play Store. But the only manufacturer I even recognize on this page is Adobe. From a PC perspective, if you ever buy a scanner or you have a printer scanner that you purchase for use at home, the software that came with it provided by the manufacturer typically has an OCR function. Abby FineReader puts out a ridiculous number of OCR programs. If you want a generic purpose one, they have it. One focused on screenshots, they have it. One for invoices, they got it. Want to build your own engine, they'll license their engine. They'll give you an OEM software version to put in your scanner. They've got a lot of them. OmniPage is another program I've used in the patch. Acrobat Pro, like many other programs out there, will let you generate PDF files where if the original was a scanned image, they'll overlay the text so you can cut and paste the text out of it. There are a number of cloud-based solutions from all your major cloud providers and some other companies such as Abby. If some of these will even take video for input and mark timestamps of when they first saw text in a video. If you want to go the open source route, there are various open source engines that have been out there for years. Tesseract was first around commercially with Hewlett-Packard in the 80s, but they've since released it to open source, and Google now maintains it. The one note with the open source engines is that sometimes we talked about all those pre-processing steps. You may become responsible for pre-processing. The advantage with some of these, especially the open source engines, is that if you want to do custom training data sets, you can do them if you have to. And there are many more products, more than I could probably ever find or list here, that are familiar with, that can do OCR work. As far from a attacker's perspective, I've considered there are probably two main ways of extracting data, at least from a computer. First is you're going to have the concept of page text, such as a database page or looking up a piece of information where you may have one or more similar records you want to copy. These will each appearing on a unique page. So in this case, you're just largely just taking snapshots. If I had to design a video engine for this, I'd largely look at the video sampling every few frames, and if the text changed and stayed to a known static state for a second or so, I'd say I'm looking at a new page of information. The other thing I consider we may have to be from a computer you ever have to look at would probably be scrolling text such as that in a web browser. Chances are someone has a very good engine that follows scrolling text. But if you don't, I would say what you could probably do here is you just hit the page down button, take another screenshot, keep doing it, and just stitch the information together for given what you saw in the previous lines. As far as results, we'll look at some results and see what we get from the pictures we had previously. Here I took a picture from the picture we had been using as our reference picture, and I uploaded it to Google Drive. And from Google Drive, you can just right click on the image and say open in Google Docs, and this is what you get. You can see how it did a pretty decent job extracting out the information from the image. Something I find interesting here is that you can tell in the fiscal year columns, while it tried to colorize them, it also read downward along the things. And the fact that we have some noise in the image did not stop this engine from processing it. Here I have Microsoft Word, not Microsoft Word, rather Microsoft Lens, the smartphone app I told it, I want you to go to my OneDrive account and upload the picture I just took as a Word OCR document, and this was the result. You can tell that it got a bit confused, not quite sure how it designed this page the way it did. Another attempt for some reason gave a better result and was interesting because it kept the colorization as best it could of each of the table columns, though it missed some fields in that attempt. Looking at this, I'm just having Microsoft Lens on my smartphone upload the Word OCR again, but this time I gave it a piece of paper. And while the perspective correction isn't perfect, you can see that it managed to extract all the information out of it. Now you may be wondering, does this mean that Microsoft's solution is inferior to Google's? That's not necessarily the case. It may be that each of them is designed to target a different environment, and historically, if you're doing optical character recognition, you're probably doing a lot of it against paper. So they may be tuned for different environments, and each may have their strengths and weaknesses, and which OCR engine you want to use may vary on the task at hand. Here I'm logged into Amazon Web Services console, and I'm looking at one of the OCR solutions, and there's at least 2 or 3 you can use in AWS. And this one is called Amazon Textract. And just like before, it can take the picture and it can extract all the information out of it. If the Amazon you could also set a tolerance where Amazon comes up with a confidence score, and if there's some possibility it didn't understand what was in the image, you can send it over to human review and set up your own board or within your company of people to review potentially text that didn't come in perfectly. Here we are looking at the image again, but this time we told Textract to look for the tables, and it went ahead and it found the table and gave it to us. It's worth noting that Textract really didn't care about the fact that I cropped this and did the perspective correction. I just gave it a raw picture of the monitor itself, and it was happy to go in and find things. Textract also can work with forms. So looking at the form we looked at before, you can see it's not a perfect scan because the member ID in this case was highlighted in the text box, and therefore this OCR engine didn't spot it. However, it was nice enough to tell us that the VIP member checkbox was selected, which is not something it'll do in a mode which is not a forms. And the sample text extract document that they show when they first start with actually is a handwritten document that was scanned in at an angle. So just to demonstrate this is a pretty flexible engine. Since we have time, I'll talk a bit about manual noise removal if you have to do that. If you look at our original image, you may notice all these wavy lines on the screen that I don't know if GoToMeeting lets go through. And you may have seen these before while taking pictures of screens, but not necessarily of a projected image. These are known as a moire pattern. It happens when the lensing in front of the pixels in front of the camera are is looking in one direction, but the lensing in front of the screen is pointed in a different direction. The fact there are also different resolution results to patterns like you see here. This isn't necessarily guaranteed to happen, or the level and whatever level of the pattern may change. I was actually able to take a picture of the screen using a different camera at the right angle and not get too much of a moire issue. So given an image like this, how would you necessarily want to fix it? The moire patterns are multicolored, and so I was concerned this might confuse some unmodified OCR programs. Image editors, if you've looked on your PC, typically have a remover for these, but while trying to use them, I was often blurring the text. But as I said before, our target is 2-color images and text tends to be 1 color, so we don't really care about anything else but the text color. So one way to do this is just to ask an image editor to give us to collapse everything to 2 colors, and given the proper settings in PaintShop Pro, this was the result. As you notice, and it came out pretty good, and this is perfectly OCR-able. Just to add more variety, I let Microsoft Word do the OCR itself this time. You may not think that Microsoft Word can OCR, but Microsoft Word can open a PDF file, and given a PDF file, Microsoft Word will then try to extract out the text and images and process them as best they can. So what I did is I took the picture in a previous page, saved it to a PDF file, and then imported the PDF to Word. And it came out pretty good if you look at it. It did not manage to convert the fiscal year line into text. It kept that as an image, but everything else came through. It's an example again here of a failure. Microsoft Word's engine didn't like the moire pattern or got confused otherwise, and kept the color image as is, just to show you that it really is importing this as a PDF file. There's an alternate method if you want to really try it. Is that an image editor, you can tell it to select the entire image. Often you can tell it to then subtract out certain colors from the selection. In this case, I told it to subtract out black, give or take a tolerance. And the result of that can then be inverted and then cut and paste for the selection, and then cut and paste into another image. And this is a good way to extract out pretty much exactly 1 color. Though here we also were trying to remove a watermark, which is something I'll get to later, which is why you see the middle number is a bit blurred, because we weren't perfect at removing it. Some related attacks. You could simply take a picture. No one says you have to OCR it, especially if you're doing it. As we kind of said with Word, you can jump through hoops depending on what you have available for an OCR engine if you think is best. If you have access to the screen and can export the file safely, you could just take this picture of the screen or script the screen. You could also just do source video capture. I'm not aware of many systems that are aware of ways of blocking that. Something else I'll talk about is accessibility interfaces, because you may not be familiar with those. Screen readers such as JAWS and other tools out there which help the handicapped have their own way of interacting with applications, and this way may be another way of extracting information out of an application which otherwise does not let you do so. On Windows, this would be through like the user interface automation framework, which historically was called in a previous incarnation Microsoft Active Accessibility. And I'm using a tool here that interacts with the user UIA framework to extract, just show you that it can highlight what's on the page. Here's the tool I was using, just showing you that it's just gone through and it's gone through the scroll window and has just found everything. If there were links, it would be able to tell me if they were clickable. It can tell me if there's, it tells you various other properties that may be useful if you are trying to make this, read this line out in a screen reader. It's some tools such as Adobe Acrobat. If you have a protected document, you'll notice that they let you independently say whether you'll let someone cut and paste tools out, and if you want to turn accessibility on and off. Though in some cases, I don't think the tools necessarily give you the option to shut off accessibility, or they just aren't accessible to start with when they're trying to hide information. So infiltrating data. This is an interesting case where if you have an OCR solution within a company, the attacker may not be able to control what is used there. As far as importing fake information, that's probably straightforward. If you're just trying to be a sales rep, putting in a bunch of random business cards to say, look at all these people I got, or you have fake invoices and you're trying to get them paid, you could probably do that to a company. The problem is the impact varies by type. If your business, just a sales guy faking it, eventually someone's going to figure out all those email addresses are bouncing, you'd hope. If the finance people are doing it, hopefully they catch eventually in an audit, but one never knows. If you're trying to put an actual malicious program into a company, I think it'd be a bit more difficult with the testing I've done so far. Because if you're trying to infiltrate a program, let's just start with this old classic program, which is the HackMiami standard antivirus test file. This actually is an executable file which works on older versions of DOS and Windows, and it just doesn't do very much besides print the string you see there. But if you give it this line in its own file, you save it in that file to this day, and you have an antivirus program scan it, it'll treat this program as if it's an actual virus. But if you try OCRing this line in, you'll find that, at least in regardless of the font I tried, a lot of OCR engines got confused. OCR engines in general were trying to figure out this is a very long line, therefore there must be a space in the middle of it, but there really is no space in it. You have a O here, which could potentially be interpreted as a 0. I've seen the curly bracket interpreted as a closing parentheses. And so in general, the engines mostly get this, but they introduce some errors in which cause the program itself to be non-executable. It's worth noting this program was carefully designed not to have any non-printable characters. In practice, most binary files you couldn't even import this way through an OCR because they do have non-printable characters. So next step, what if we base64 encode a program? Here's a very simple program, just says hello world again. And in the base64 encoding again, base64 does not care about white space. Therefore, we don't have to do that. And there's only a limited number of other characters besides letters. But still, do we have I's in here, or do we have ones? Do we have zeros or A's? Programs often try, and I saw attempts to try and put this in. I saw some cases where certain engines were just skipping lines when I had multiple lines of base64 in a file. So, but it's hard to say, but I get the sense that you probably have to go to a lower base, and there are encodings that be like base 27, which are specifically designed not to have any characters which are confusing to an OCR engine. So you could do this. But in fact, OCR program reconstructions programs has been done. Most potentially famously was the pretty good privacy encryption software was exported from the United States back at the time when you couldn't legally export the binary as a book. And in the book, the program source code was printed in an OCR scannable font. Several copies of those books were then scanned in Europe, and then the results recombined and hand-checked to create a version of the PGP program in Europe that could be distributed internationally without the restrictions the United States was putting on it. But character accuracy when you're doing a program import has to be very accurate. You may need to know a specific font or tell the OCR solution what you use. If you have a solution like Tesseract for the open source project there, you can tell it, I want you to run in character mode. And that may actually work better because there's no real prediction of a word here. You made an OCR program trained to handle this kind of data or scanning if it is a smarter system. I think a lot of the problems they ran into is trying to figure out what language or words or whatever was actually going on there, but they weren't able to figure out. But this level of control is not exposed in many programs. If you are targeting an OCR solution, you might need more information about what it is in order to help you exploit it and get a better try in the first point. Using base 64 encodings can help you by bypassing some of the characters that aren't it, but then you're going to have to decode on the other side. And if you're not using something like base 64, you're going to cause additional problems because you have to compile, have some program somehow on your other side which can do the decoding, and if it's a bit non-standard. You can also add checksums or error correction encodings, but those definitely have to be decoded. Similar techniques, though, may require to infiltrate or exfiltrate encryption-related data. A lot of encryption keys are either stored in a binary format or a base 64 encoded format. So the general sense is you could use these as a good start if you're trying to do that. But if you only have a few encryption keys you're getting rid of, this might be overkill, and you're going to have to do manual correction after the OCR anyway. Some countermeasures. Watermarking, we're going to focus on visual watermarks. If you're just putting yellow printer dots or some other hidden watermark, you're probably not going to screw up an OCR engine. These are meant to be theft deterrents. These may include information about the user session being used. You may put the username in them, session IP address, things like that. This presumes, in general, though, that text cannot be extracted in a way that does not preserve the watermark. And as we talked about, we only really care that the text on this page is black, so I don't care that the watermark in the back is orange. These need to be present, but not overly obtrusive. Otherwise, you'll slow down the person's job who's working on your task's work. If you're generally speaking, if you're trying to work with photos, a research paper from Google shows how watermarks can be removed from photos. The catch very easily, actually, given enough samples. The catch is you need a static watermark that doesn't change. But even if you add slight randomness, as they show, that can make watermarks harder to remove, especially with photos. But that may not be a concern with OCR if you only have some slight stuff. In terms of protecting this in terms of computer software, if you have a watermark when a user is using a database and the user is showing includes the user's timestamp, like this is the time they started the session, that may also help because you're not going to get a lot of samples of data if you keep changing the time or IP address that the user shows up is coming from. And as we talked about it, we're concerned about the things that are the same color as the text primarily. So here's the image I was talking about where I added an embossed watermark. I even added dark top to the embossed watermark instead of letting it be cleared through. Maybe a bit hard to tell through the meeting, but the text actually gets bluer when it's over a blue section and just becomes plain gray when it's over a white section. But as discussed, if I just do a 2-color conversion and just extract out what's pretty things that are around the color black, we pretty much get rid of the entire watermark and then can scan this in. You can see there's some marks around the 239, which may make it hard to OCR, as well as the M above. But other than that, we've done a pretty good job of extracting the image. Here we have an example of a watermark, which is actually the same color as the text color. It just has made up of very tiny black dots. So your eye interprets it as gray, but you can still read the text that's over it. Again, this is possibly, some OCR engines didn't seem that phased by this when I tried it. But I also tried doing it by helping the OCR engine by forcing everything I could extract out just to get the black image of the text in the dots in the watermark. And then I just removed what was referred to as salt and pepper noise from the image. And that got dimmed the watermark enough to make any OCR engine I try pretty much process it. Alternatively, this could be a lot of work to remove. Say instead of dots, I had used stripes. You still probably could read this page, but the stripes crossing the letters would be a lot harder to remove. You could also try, if you're trying as a countermeasure to avoid direct recording, if you have HDMI ports or DisplayPort, you may be familiar with high bandwidth digital content protection. These are attempting to keep you from copying things like Blu-ray discs, and so you can't just store them elsewhere or distribute them on the internet. On the Windows, you're using a protective media path to request this. On Android, you're going to set the secure flag on a window. And when you do this, it may turn on HDCP and try and protect you from extracting the direct recording by attaching a video recorder, but you're still going to be able to take a picture of the screen. If your software has good enough access to the operating system, you could try enumerating the attached video devices, look for a splitter or something like that. Catch is you don't necessarily know if someone's using a splitter as a video extender because they're in a conference room and that's the way they're set up. Or you're not necessarily going to have a known full database of bad devices or good devices. And again, you can always point a camera at the screen. Disabling screen capture is something that keeps coming up. Again, Android secure flag. I believe Windows 10 also has a Windows flag that lets you do this. The catch is that does not necessarily stop a non-standard screen recorder that does not use the operating system's default way of capturing a screen. And again, it does not stop you from attaching a device in the back that does the screen capture, and it doesn't stop you from taking a picture. Some internet sources claim you can rapidly flash information to avoid a direct recording. My response back to this, yeah, you may have confuse a video codec, but if I have a camera again in front of the screen, I can control my shutter speed and ideally get the information I need. As we talked about, you can add noise or other amounts, the same color as the text to confuse OCR. You can also show a graphical window if you're trying to stop an accessibility interface, though I don't know if that's not necessarily going to stop something that's familiar with OCRing, though. You're trying to protect your data. Probably the easiest thing is only show a limited amount of information that the user needs access to. If the user was verified from another system, you don't necessarily need to show their credit card information or anything like that, not related to the reason that the user is calling. You could also show different data to different users, not necessarily just by role, such as a call center employee and their supervisor, but you could also show when you have you say a test user calling all your call center, you could have that user identify as John Smith to one representative and Steve Smith to another. And that way, if there's a data breach, you could potentially identify where it came from. Corporate policies and training are a form of control. You can always, when I was trying to figure out what the current percentage of an insider threat employees currently were as I see this is primarily an insider threat, but I've gotten varying results depending on how groups spin the information. You can also do employee monitoring. Uh, uh, I would say that this is like when there's students are studying stuff remotely from home now, and they have their webcams have to be turned on. But even then, some kids are finding out ways to cheat or point their smartphones at the screen in a way that webcams don't necessarily see. You can use endpoint data protection, data loss preventions. These are the things keeping you from using the USB ports on employees' computers. Not all employers use these, but if you did lose information, they could potentially help you track down who was looking at the information, or if they did anything suspicious, like try and email a screenshot to themselves. And I put presuming the user will care if they caught here, because I'm not necessarily certain that's as strong as a deterrent as some people think it is. I mean, whether you believe in a certain country, which is believed to have 1,000 grains of sand approach to exfiltrating data, or if just in general the user wants their way of doing things, it's like shadow IT, they're going to try and do it anyway. But in conclusion, if a human has to see it, other devices can capture it. That's just generally what the rule is. I consider, in my view, OCR may help you perform a medium-sized data breach, but it may be too complicated for smaller and potentially larger compromises. If you have a small compromise and you're only looking at one or a few pieces of information, it may just be faster to type write everything, reproduce it by hand if you're trying to obscure the origins. And if you have a large compromise, hopefully you've just broken into their database. If it's a case where, say, you have an employer who uses a call center and they're using a solution like Citrich's remote desktop and app product, which has gone through many names, or VMware's Horizon, and that's the best access you can get, then you could do OCR, but it's going to potentially be a lot of work to extract that information as it slowly appears. And that's all I've got. So questions? Let's see.
Thank you very much. That was a awesome presentation, as I expected you to do. So I guess there are some questions already. Have you been answering them?
Well, I saw them coming in, but I haven't looked at it.
Okay, did you answer some of them, or
Let's
are
see.
we?
Hector says when he was trying to do some web scraping on a project, he ended up using a snapshot in OCR to pull the data. He was wondering if that was a common practice. What some systems are trying to block. I don't know how many systems block web scraping, or I do a lot of UI automation, so it hasn't necessarily been an issue with what I've done, but I'm not like Ticketmaster or someone trying to block bots from being scraped, or Amazon coming through and just looking at all my prices and updating theirs in real time in response.
Right.
So, but yes, you can always use you could take in a snapshot in OCR to pull data. It's also historically was a very common practice for screen scraping, where if you have a legacy system like a mainframe and you wanted to put a web printout on it, at least in the beginning, you were doing things like you would have one system just fake out being a text terminal and interact with the mainframe, and then the results would appear on the web page. So that's an older, screen scraping is a very old technique. DSM recommends Hylafax as another open source engine. I didn't list all the open source engines out there because I'm not very familiar with what the status of all of them are. T-Rays, just using, because probably Hector says terahertz rays to scan the book without opening it. It applied OCR to read out pages. Yes, there's been games played like with paintings where they would scan to see if there's a painting underneath the painting as well. Because a lot of older paintings by the masters, they just reused previously used paintings that people didn't care about. I know there are a lot of automated book scanners as well, but they typically require you to open the book. I mean, I have one. I don't use it very much. but you just put the book flat on the page with a thing at a known the binding in a known position. You take a picture, and then they automatically take an image from an above head camera and flatten it, and then they flip the page and take the next page. You have to, mine is very manual, but I'm certain when Google did all their OCR scanning, they were using much fancier systems to do it. But
Any other questions?
I still see some sites are using captcha also. I thought that should be very outdated now. So with this OCR thing, one could put a bot in front of a computer and defeat the captcha stuff, isn't it?
Well, you could put something in front of a computer and capture it.
Well, yeah, right.
But if you're talking about captchas,
Yeah, captcha.
People have tried OCR captchas. You can look into literature. People try to OCR captchas all the time. Sometimes there's back doors where they found the audio captcha option of a captcha was easier to process than the written captcha. So they would click the audio help desk link. Alternatively, you could just farm out, as has happened to a bunch of users, the captcha and just have them answer them in near real time.
Okay.
But there are also some graphic captchas the OCR cannot solve.
It's the OCRs. It depends on the type of captcha. If you're just showing a text and saying with some lines through it, yes, that maybe OCR can solve. If you're going to what Google reCAPTCHA is doing now, where it's saying identify all the chimneys in these images, right, or all these sidewalks or lights, and you don't know if they're necessarily want you to select the pole or not. Those types of things, an OCR solution is not going to solve on its own without a lot more artificial intelligence stuff tied to it.
Yeah, and as they say in security, it depends on how much you are willing to spend. Because if you were to look at the self-driving cars, the reason why they are able to self-drive is because someone has spent tons of money to take a lot of images, millions of images, and load it into the chips so that they could look through very quickly and make decisions. So even the so-called chimneys in the picture, if you were to load all different images into your bot or so, then they will still be able to solve a bet. The cost, are you willing to actually spend that amount of money just because you want to hack some site or so? That's the question.
Well, I was gonna say I'll also point out that you can't necessarily fully rely on OCR. You need context, for instance, or your system has to be smart enough to realize things. For instance, in southern Georgia, I believe on Interstate 75, you will have signs that say speed limit 70 miles per hour. Then you will have separate signs not stacked underneath the other sign that says minimum speed 60. So if you look at one of my GPSs, it keeps going back and forth, the speed limit on that road being 70 versus 60. And if you have a newer car, which also is trying to show you on its own little heads-up display that, oh, I just saw the last speed limit sign was 70, and then you go to the 60 area, and it says, oh, the speed limit sign says 60. Is it suddenly going to slam on its brakes if it's speed limit and if it's on cruise control and say, oh, I have to slow down now, even though it misread the sign?
Yeah, interesting.
Any other questions? All right. Then we'll see you guys soon. Remember to join us at the Slack or Discord. And I'll thank you very much for coming. And thank you, Sam, again. Awesome job.
Hey, Rod. I thought after the presentation you were going to talk about folks because we actually try to do this as our OWASP or so, that yes, people come in to OWASP for CPEs, maybe perhaps to keep in touch or get up to date to the trend also. But another one that we also want to try to do is so the new folks who may be interested in actually breaking into this security field, because yes, you said there are tons of jobs, but when you want to apply, they say you don't have experience. And then
Right.
at times, if you have experience, they will say you don't have CISSP. And then once you have the CISSP, they go back again and say you don't have experience. So what would be your advice also, or anyone on the, at least on the meeting also, that you will actually advise folks who are trying to break into this field, like they have experience in credit card tokenization, experience with privacy, and perhaps a little bit of project management?
Hold on, let me actually, I'm going to stop the recording